Hi, this is Matt. In today's video, we'll look at example problems of circles and trigonometry. Specifically, we'll use information about the unit circle to determine possible values for angles, and we'll look at arc lengths and radians in the applied setting of gears. In this problem, we need to find values of x between 0 and 2 pi that satisfy both of the following conditions. 1, that sine of x is less than a half, and 2, that cosine of x is less than a half. So if I start with my first one, sine of x is less than a half. Well, sine is the y value, so that occurs at pi over 6 and at 5 pi over 6. So that's where the y values are a half. So I could draw these angles in, and it's anything less than that, so that the y values are less than that. So that would be anything within this shaded region here. So between 0 and pi over 6, and 5 pi over 6 to 2 pi. All of those angles would satisfy the first condition. And the second condition, cosine of x being less than a half, well, cosine of x being less than a half occurs at pi over 3, because it's the x values, and I can go down here, and 5 pi over 3. So any of the angles, anything less than here to the left, will satisfy the fact that cosine of x is less than a half. So the overlap shown here, that will satisfy both of the conditions. So in this case, we have x needs to be greater than or equal to 5 pi over 6, and it needs to be less than or equal to 5 pi over 3. So that condition, all of those angles will satisfy both the fact that sine of x is less than a half and that cosine of x is less than a half. One of the applications of radians and arc length is looking at gear ratios. And when a smaller gear is used in terms of a larger gear for the drivetrain, it results in more power. And so here we have an instance where we have a smaller gear having a radius of 3 centimeters and a larger gear having a radius of 6.4 centimeters. And the question asks, if the smaller gear rotates 170 degrees, how many degrees has the larger gear rotated? Well, we can use arc length because if the smaller gear rotates 170 degrees, the distance, its arc length, will be equivalent in the larger gear as well. So those two distances should be equal. So I can say, well, S being my arc length will equal the radius of, in this case, we'll look at the smaller gear, times the angle in which it's rotated in degrees, and we'll convert that into radians because that's what we're working with. Everything in terms of radians, so pi over 180. So now we have arc length equals, our radius is 3 centimeters, times 170 degrees times pi over 180 degrees. So we know that our arc length S equals, if I simplify this out, this is 17 pi all over 6. So I can use that information now to look at my larger gear. So I know that the arc length, being 17 pi over 6, will be equal to the radius of now my larger gear times the angle in which it gets rotated in radians. So I enter that information, well, 17 pi over 6 being my arc length will equal, my radius is 6.4. I'm trying to solve for theta in terms of degrees, and the conversion factor of pi over 180. So now if I solve for theta in terms of degrees and I simplify this out, the theta is roughly 79.6 degrees. So I solve for theta, so that means that the larger gear has rotated 79 degrees